In this video 3-3, we will be looking at solving inequalities using multiplication and division. By the end of the video and work time in class, you should be able to say, I can solve inequalities using multiplication and division. With the multiplication property of inequality, if C is greater than 0, if A is greater than B, then A times C is greater than B times C. And the same is true if A is less than B, then A times C is still less than B times C. So basically what this is saying, take an inequality, for example, like -2 is less than 3. If we take both sides of the inequality and multiply both the -2 times 2 and also the 3 times 2, what happens is we're left with -4 and 6, and that inequality symbol is still the same, where -4 is still less than 6. So if you're multiplying both sides of an inequality by that same value, when C is greater than 0, it remains the same. Once again, that property of whatever you do to one side, you do to the other with equality also works with inequality here. Now, when C is less than 0, you're going to see something happen here. So let's say I have 3 is greater than 1. And I take and multiply both sides of this inequality, and I multiply, let's say, by -2. And then I would do 1 times -2. And then I would have -6 and -2. And so if I look, wait a minute here, -6 greater than -2, we know that's not true. So whereas up here, the inequality stayed the same when we multiply both sides by 2, something happens here. If you're multiplying both sides by a negative, you have to reverse the sign, because multiplying by a negative makes it the opposite. So this is key right here. Notice once we multiplied both sides by a negative number, we had to flip the sign around. The same here in division is true. If you have something greater than some number greater than 0, if you divide both sides by C of an inequality, it remains the same. So if I had 6 is greater than 3, and I took 6 divided by 3 and 3 divided by 3, which then would be 2 and 1, 2 is still greater than 1. It stayed the same. However, when that C is less than 0 and you divide both sides of an inequality by that C, what happens is similar to the multiplication, where the C was less than 0. If I had 6 is greater than 3 and I divide both sides, let's say, by -3, we would end up with -2 and 1. And if I kept it the same, that's not true. We have to reverse the sign the minute we divide by a negative. So if we have x divided by 2 is less than -3, to get that x alone, the opposite of dividing by 2 would be multiply by 2, multiply by 2. That simplifies to 1x. X is less than -6, and then we would graph that as well. And we have -6 to the left. It would be an open circle shaded to the left. So anything shaded would be a solution to this inequality. So we can check our work. We could take a number that would be shaded, like -10 is shaded. Plug -10 in for x. -10 divided by 2 would give you -5. -5 is less than -3. That is true. So that is correct. -2/3 w, so this means times w, is greater than or equal to 2. So to isolate the w, we want to get rid of the -2/3. I want to multiply by the reciprocal on both sides. So this simplifies to 1. 1W. And if I do 2 times negative 3 halves, if I write these as rational, reduce, a positive times a negative gives me negative 3 over 1, which is negative 3. Now notice I multiplied both sides by a negative 3 halves. Because I multiply both sides by a negative, I have to flip the sign around from greater than or equal to less than or equal to. This would be your solution. And then with the graph, here's 0. Let's say negative 3 is here. It would be closed because we know it can be less than or equal to negative 3. W is anything less than or equal to. So we're going to shade this direction. So we could, you can pick any number that is shaded in and plug it into W, and you will see that it works. A cheerleading squad earns $5.50 per car washed. How many cars does the squad need to wash to earn at least $77? So 77 is minimum. They want to make at least $77. So it's $5.50 per car wash. And we know that they want to make greater than or equal to, because it said at least. And at least would mean that 77 would be okay. But I'm sure they'd want to make more than that. So here's our inequality. So you have to be able to take words, write the inequality using our math symbols. To get the C alone, we divide by 5.5. On this one, we would not flip the sign around because we're dividing both sides by a positive number. And so we would get C is greater than or equal to 14. So at least 14 cars. Negative 5a is greater than or equal to 20. So if you have negative 5 times some number a is greater than or equal to 20, if you divide both sides by negative 5 to isolate the a, reverse the sign since you're dividing both sides by a negative, negative 4. So anything less than or equal to negative 4. So our graph, closed circle, and less than or equal to negative 4 would be shaded to the left. Find something that is shaded, plug it in, and you will see it works. Can you say, I can solve inequalities using multiplication and division? Write a summary and reflection and be prepared for the work time in class.